In this video, our goal is to be able to write equations relating two or more variables. So before we go into how to write an equation, we're first going to go over a quick example. So we're going to pretend that someone named Kyle can run 150 meters every minute, which is pretty fast. Now, knowing that he can run 150 meters every minute, we kind of have to ask ourselves, well, what if he runs for 2 minutes? So now we're assuming that Kyle runs this at the same rate every 150 meters he can finish in 1 minute. So if he's running for 2 minutes, most people would say, well, I can multiply 150 times 2, and that'll give me 300 meters. Now, for example, how far will he run if we give him 5 minutes to run? So he still runs 150 meters every 1 minute, but now we're multiplying that by the 5 minutes because we are giving him 5 minutes to run. So 150 times 5 gives us 750 meters. Now lastly, how about if he runs for 10 minutes? So again, the 150 will not change because that's what he runs every single minute. But what does change, what does vary in fact, is the 10 minutes that we allow him to run, because now he'll be running 1,500 meters in those 10 minutes. So when we want to write an equation, we need to remember that the variables can change. All right, that's why they're called variables. They vary. Now, in this example, the thing that doesn't change, the thing that's constant, is this 150. And this is actually a unit rate. So I know that 150 times 2, 5, or 10 gives us 300, 750, or 1500. And in this example, we have to remember that the 2, the 5, and the 10 all represent the number of minutes that this person runs. So I'm going to put an M to represent the minutes that this person is traveling. Or in fact, let me use T for time, just for this example. So 150T for the time that we allow him to run. In this case, it's 2 minutes, 5 minutes, and 10 minutes. And when we multiply, when we take the product of these two values, we end up finding out how many meters he's actually run. So we're going to put this M for meters. So 150 times the number of minutes, in this example it's time, is equal to the number of meters he runs. So what we're going to do is we are going to create a couple of equations, first using unit rate, and then from there using our two variables to create our unit rate. So the first step to create a unit rate is to decide what variables we're comparing. So in this example, a flower needs 3 cups of water per week. We know that we're comparing the cups of water to the amount of time, which is in weeks. So I'm going to write a ratio that compares the 3 cups of water to the 1 week. Now, luckily for us, this is a unit rate already because my denominator is already equal to 1. The second part, actually I moved up a little bit ahead, is we need to find our unit rate. So our first part was finding the cups of water and knowing that we have to compare that to weeks. Our second portion of this was to find a unit rate. So remember, unit rate means per every one, so there are 3 cups per every 1 week. And most times, you can write this down if you'd like, most times the unit of time is the denominator, not all the time, but a large majority of times the unit of time will be our denominator. And question 3, you have to think of a small example to help you set up your expression. So what I mean by that is, let's imagine for a second that this person is watering their plants for 2 weeks. So most people would be able to say, well, the 3 cups of water times the 2 weeks that you need to water them gives me 6 cups of water. So the 3 represents our unit rate right over here. This is our unit rate. This is what it represents. That stays the same in our equation. Most of your equations are going to have a unit rate or a constant of proportionality, if you guys remember that from October. And so this is going to stay the same. What changes is this variable 2, right? This could be 2 weeks, it could be 10 weeks, it could be 100 weeks. So in order to represent that it can change or vary, I'm going to put the variable W, because they get 3 cups every week, and our 6 represents the number of cups that the person is watering the plants with. So our first equation is 3W equals C, or 3 times the number of weeks gives us the number of cups of water that we need. Let's go over a few more examples before we move on. So in this example, we have that Robin spent $350 in 4 days. So my first step is I want to see what we're comparing. Well, looking at this, it looks like we're comparing the amount of money to the number of days. So I already know I'm comparing money to days, and now I need to follow step 2. So I'm done with step 1. I need to work on step 2, which is finding the unit rate. So using these pieces of information, that there are $350, I'm going to use M for money, and that this was spent over 4 days, I now need to find my unit rate. So remember, unit rate always has a denominator of 1. So in order to figure out how much money she's spending in one day, I divide 350 by 4, and in fact that gives me $87.50. Remember, this is just in money. So now we need to think of a small example to figure out, well, how much money are we really spending, and this will help us set up our equation. So let's imagine that this person is spending her money for 10 days straight. So we have $87.50 times 10, and that's going to equal $875. Now to set up our equation, we have to remember our unit rate, our $87.50 right here, stays the same. We don't change that. What does change is the number of days she spends money. For instance, she could spend it for 5 days, she could spend it for 20 days, she could stop at 36 days. So to represent that, we're going to say that instead of 10, we're going to put the variable D. And this is equal to the amount of money that she earns at the end of the week, or that she spends at the end of the week, which is M. So 87.50 is multiplied by the number of days to get the amount of money that we need to get. In this example, we talk about how the average American uses 189 gallons of water a week, and we're comparing that to the number of gallons that somebody uses for a day. So our first step, we have to compare the number of gallons to days. And this is a little bit tricky because if you look at our first example, it actually says that we're doing this by week. But at the end, it's asking us to compare it to days. You have to be really careful about that and make sure that you're comparing the correct amounts. So for part 2, we need to find our unit rate. So while we know we have 189 gallons of water, and while we know this is spent in a week, we need to know how many days are in a week. So you should obviously know that there are 7 days in a week. And if we find the unit rate, we learn that 189 divided by 7 is 27. So we're using 27 gallons on average for every 1 day. Now let's think about this. Let's come up with an example. Part 3, if we're using 27 gallons every day and we use it for 2 days, 27 times 2 is equal to 54. So this is telling me that my unit rate of 27 times the number of days that I'm using the water is equal to the number of gallons that I'm using. So my equation would be 27D is equal to G, or 27 times the number of days is equal to the number of gallons we're using. If you have any questions about this assignment, as always, please feel free to email me, and please make sure, remember, one little tip, for question 1, you already have your unit rate. You have it. Okay, and I'll give you a clue. That is, I believe, 3 hours over 1 day, because we're comparing the number of hours the person's working to the number of days they watch TV. For number 2, you have to be really careful because it says that we're comparing 1,200 gallons to 2.5 hours, but then if you look closely, it's actually asking for the number of minutes. So before you can solve number 2, you got to make sure that you find out, well, how many minutes are in 2.5 hours? Again, if you have any questions, always feel free to email me.